Okay, it's day 311 off the grid, and today I have done a bit of serious electronics work for the solar setup, and this is it here. Here we go. This is it. Now what is this, you may ask? Well, this is my current boosting circuit that will allow me to run a couple of extra solar panels on my BP charge controllers without any danger of overloading them and popping a MOSFET inside or something silly like that. This is the final circuit design I came up with, and it uses MOSFETs, which is funny because I've got this baggie here. There's a 2N3055 power transistor, and then there's all these supplementary resistors. Well, that's actually enough to build two of these. But I haven't done any of that, I haven't used any of that, and the reason why it turned out was because those BP charge controllers shunt the solar panel when they reach their charge, which I found really odd, considering that they are actually a common positive charge controller. Normally if you do a shunt method, then you can get away with keeping the negative as common, because you can use an N-channel MOSFET to shunt while still driving it. But I don't know what's inside it, but I know that they shunt the output, so therefore this method using these bipolar transistors as a current bypass will just simply not work at all, because when it goes into shunt mode, this will think, yippee, lots of current to pass, and it'll keep charging the battery. Well, that's no bloody good. I went through gazillions of different configurations of design trying to come up with a circuit that would do the job, but in the end I realized it was only possible if one made the use of these opto isolators here, opto couplers, because it needed a certain level shift that just wasn't going to happen any other way. I tried heaps of different configurations of schematic and they all suffered from one fault or another. But this is the final circuit, and as you can see, it's actually quite simple, although every single component on there has been rather well thought out. The original building of this didn't have the Zener diode, but I realized in the end that was utterly necessary. So what the Zener diode does is it clamps the gate of the MOSFET here to stop it from going over 10 volts. That's really important, because we do have a situation where right at the moment that this circuit turns on, the voltage across here will be the full open circuit solar panel voltage, which is 20 volts. And without this Zener, the voltage at this point could easily rise above the 15 volts that this MOSFET will tolerate. So needed the Zener diode. And because we had the Zener diode, this 150 ohm resistor here became necessary to limit the current that would flow when that voltage is 20 volts. See, as soon as the MOSFET turns on, the voltage is pulled down at this point to whatever the voltage the battery is at, so it's normally fine. It's just at that moment, just in that nanosecond or whatever, where this turns on but this hasn't turned on yet. It may not have even been an issue, but I think when it goes into PWM mode and that's turning on and off really fast, I don't want to keep hitting this MOSFET with voltages higher than 15 volts. So that's why that was necessary. The 1K resistors are pull down resistors, so that when this turns off, when this photo transistor here turns off, then the MOSFET will be pulled down and turned off. Of course, that's the photo transistor part of the opto coupler, and that's the infrared LED inside the opto coupler. That's why they're drawn like that. We've just got a pilot LED in series with it, which, as you can see, is on here. Now this, of course, is two circuits. It's like a stereo current boost, if you like, because it's for my balanced charge controller setup in the B shed using the 2 charge controllers, so I need 2 channels essentially of it. But they're both built exactly the same, well, exactly the same schematic anyway. Physically there's a few little changes in the way the components have been chucked on the board. Kind of built this side up here as the prototype, had to change a couple of things to get it right, and then I just built this one up in no time because I knew what I was doing. All the major components from here are second hand. These came out of an old UPS board that I was slowly been stripping of the MOSFETs, and these are the, well, there's only one more MOSFET left on that board now that these 2 have gone. This nice heatsink here, complete with the bushes and insulating washers and stuff, came off another old board. The opto couplers came off an old board. I was just going to hack them out with a knife, but I found I could desolder them, which was quite surprising because it was a double-sided board. And this variboard, look, it's an ancient variboard. It's massive, but those tracks are thick enough that I can do the high current wiring right there on the board without having to boost it up. Yeah, as you can see, there's a Zener diode soldered on the back. That's a bit naughty, isn't it? There's a few tracks that were broken, and then I decided to unbreak them too. But on this side, the Zener diode is actually just bunged in the same hole. I don't know if you can see that, bunged in the same hole as the resistor. So, yeah. But yeah, that's what I built largely out of scrap parts. I even got these as scrap. They're not second hand, but I got them in a big baggie for very little. So I'm going to install it. Well, I don't know if might be busy tomorrow actually, but I wanted to build this up ready to go. I've been umming and ahhing of doing all sorts of different things to get the extra solar panels connected to that circuit. One, of course, was just buying a couple of slightly bigger charge controllers, but I really wanted to use the BP ones. The other was to just put the extra panels through a couple of extra charge controllers. Well, I could have done that, and I was almost going to do that, but I decided not to because A, it was going to be difficult to fit them on the panel I've got in the shed. It was starting to get a bit crowded on there. I needed something a bit smaller, and B, I kind of wanted the BP controllers to act on their own without any interference from another charge controller with slightly different patterns going in there. So I think this was a good solution. And C, of course, is something that I actually built, something that I actually kind of invented, I guess, or developed at least, you know. So that's kind of a bit more satisfying, but we'll see how well it works when I hook it up, and no doubt I'll make a video of that for one of these off-the-grid vlogs. So yeah, I've come up with lots of different ways now of boosting the output of small charge controllers. The beauty of this one, of course, is you don't have to make any modifications to the internals of the charge controller you're hooking it to, so that's quite cool. And these being opto-isolated, it doesn't necessarily need to be used with a shunting controller, although we'd have to do some rewiring a little bit, but it could be used also with a series type controller. But yeah, I should have got into these opto couplers a while back, because it would have made some of the other circuits I've done a fair bit simpler. And of course, using the opto couplers meant then it was easy to use MOSFETs, so I didn't have to use bipolar transistors. In fact, using bipolars with the opto couplers would have been really difficult, because these just simply wouldn't supply enough current to turn on the heavy base loads that these sort of 2 and 305s actually need to fire up properly. So you'd have to use another transistor just to provide that current, so you'd end up with quite a complicated circuit, and with some big resistors like you see here. But with the MOSFETs, of course, it's all done by voltage, so the resistors, little tiny wee resistors there, and you know, it's kind of cool. And this just follows the PWM, although this would have too. So, but there we go. This is getting so long just to show this little circuit, but I'm kind of pleased with it. Spent all day on it, you know, kind of got it going. Well, I've tested it, you know, dry tested it just with these batteries here to make sure it does what I expect it to do, but it'll be cool to hook it up. So there we go, day 311 off the grid.